Welcome to Power Summit 2023.
Please welcome with a big round of applause Mr. Ananda Chowdhury, Treasurer of IPPAN. We'd also like to invite our presenters and panelists on stage. Mr. Janan Malovic, Senior Hydropower Engineer, the World Bank. Ms. Abhigya Malla, Vice President, High Himalaya Hydro Construction Private Limited. Mr. Gaurav Mathur, Country Head, Trina Solar India. Mr. Takeshi Kikukawa, Hydropower Planning Advisor to NEA, JICA. Mr. Prabal Bhattrai, KNA Consulting. Mr. Namit Anija, Regional Sales Head, North and East India, Nepal, Sungrow India. And with him, we complete our fantastic panel for the 10th session. Now, without any further delay, I'd like to hand over the proceedings of this session to our moderator, Mr. Anand Chowdhury.
Thank you, Alicia. Good morning, everyone. So today we have the session for Project Innovation and Technology. As you all know, that in Nepal we have history of more than 100 years for hydropower. And for solar, we just begin, I think, 3 more or so. So we'll talk about hydropower, construction especially, and more about how captivity. We'll talk about NEA, how NEA is planning for their future. So first of all, I'd like to call Abhigya Malla for best practice in construction of hydropower projects, as they have long history of 14 years of hydropower construction, and she's young, and she take forward her company for best practices in hydropower projects. So Abhigya, you can present your.
Hello, respected guests, panelists, ladies and gentlemen, a very good morning. So I'll be talking on the best practices in the construction of hydropower sector. So fairly, my evaluation and based in our construction company. So can we please have the slides? Thank you. Okay, so do we remember the schedule? It's the 16-hour load shedding schedule and also heavy imports that we used to have just a few years back. And now in 2025, we are going to be self-sufficient in terms of energy, and we'll be exporting in the wet season. In terms of megawatt as well, in the last 3 years, we've done quite a work in terms of generation, and this effect will be multiplying. So coming back to the topic after a brief introduction, I would say there are several factors, especially innovation and technologies, that has aided towards the growth or our success story very recently. We're not yet there in our vision, but however, we're doing quite a bit. And I would say earlier the problem was even just 10 years back, it was very difficult to reach our sites, especially to run the software, and the mobile solution wasn't available. So now most of the remote places are also well connected in terms of communication. From labor intensive, we are now capital intensive in terms of certain segment. especially our projects have tunnel work. So when it comes to drilling, shotcreting, everything is now capitalized. And it wasn't just the limitation of the contractor earlier, because our banks were fairly of smaller size. Even the letter of credit and bank guarantee used to be a problem or a constraint. However, now we have financial institution that can fund that as well. In terms of capital injection, I would say a lot of international institutions as well as our own Provident Fund and non-resident Nepalese group have also capital injected in this sector, which has helped us to grow in our potential and capacity of our development work. We're not yet there in our vision of 10,000 megawatt in 10 years. However, we are somewhere, and we hope to achieve this quite fast. And in terms of framework, guidelines, and processes, there are a few organizations that have ISO standards and also follow guidelines of IFC and USAID. And the large size hydropower projects have also got their support, which is a very good thing. In a few years, we see large hydropower projects being developed by international investors as well. However, now I would say we have in-house contractors, consultant, and financial institution. We're capable of making more than 100 megawatts on our own. So in terms of knowledge development and human resource, experienced human resource development, we have reached quite a height in last few years. Earlier, as I remember, in just 1 to 5 megawatt projects, we used to hire international consultants or contractors and their expertise just to finish the project on time. Now we are self-sufficient in that way. In terms of model of construction as well, earlier we used to work in bills of quantity model. Now it is engineering, procurement, construction model. Soon we believe EPCF model will also be introduced. There are a few doing as well in small scale project. In terms of manufacture and production also, as we can see, cement industry, rebar industry, even construction chemical industry is now set up in Nepal, and there is competition amongst them, which is keeping the prices bay. A few years back, even cement and rebar used to be imported from our neighboring nation. So this is something that has changed. And in terms of software also, we used to use internationally imported softwares, but now we have customized software. It's very easy to do to and fro and to work with them. In terms of investment as well, earlier our shares used to be undersubscribed, especially hydro shares, and now it's oversubscribed. So I think the public interest and understanding also has changed. There is some certain level of awareness. The most essential skill that we have is our knowledge and expertise in our geology and geography. So over time we have collected, calculated, analyzed a lot of data, and we can do better than and be cost effective in terms of taking new projects. So just few things here and there. When we talk about the contract implementation and resolving the disputes, now most of the contractors follow FIDIC rules and regulation. If not, we have to follow because it is international guidelines, and we need to follow because it's proven as well. In terms of employment, like our company now has 14 projects, so 2,000 to 3,000 is, it depends on the season, but in the peak season up to 3,000 people are working along with the subcontractors. So in terms of equipment as well, I see safety equipment especially. We are aware now, even in the grassroots level, avoidable incidents have been minimized, and we can remotely work, especially post-pandemic. We've been remotely working, and these softwares and all these things have been applicable and helped us in the growth. However, as you can hear from the other panelists, they will be talking about pump storage, PROR projects, energy security, or hydrogen or something. We are not yet there. However, domestically, we have come till here, and we are hoping to practice better and also do better sized projects than this. We have a short history, however, we have a long way to go. That is why I would like to end by saying the quote, "These were the best practices." I mean, construction sector has evolved. It is evolving. However, implementing best practice is copying yesterday. Innovation is inventing tomorrow. So we need to keep on innovating so that we can meet the demand. And as we can see in the last summits or regional summit as well, if we cannot cash this heated interest of everybody into business and our perspective, we are again going to miss the flight. The world has a demand for our hydropower project, and we all need to work for that. Thank you.
Thank you, Abhigya, for your presentation. We'll come back to you again if time permits. Now, from hydro, we'll come to solar. So, I'd like to call Gaurav Mathur from Trina Solar to present about solar PV technology.
Well, good morning, everybody. Can I have the slides? So good morning, everybody, and I am Gaurav. I am from Trina Solar, which is a solar PV manufacturer, and we are one of the biggest in the world, having a capacity of more than 65 gigawatts annually, and we have completed 25 years. So we are one of the few companies who have completed the life cycle of the product. Like for solar PV, it is 25 years. So I'll take you through to my small presentation about the company, about the products, Well, we know that Nepal is a primary source of renewable energy. Nepal is hydropower, and I believe most of us are from the hydropower background. But solar have also started a bit, like from Trina itself. I think we have shipped more than around 30 megawatts of module, in different utility projects, as well as on the standalone projects. So I think the thing is still it is catching up. I believe it is too early, but yes, we see it's a very bright future, and because of the potential which Nepal has, is basically what we foresee is if you install solar panels 1% of the land, so that will be sufficient for for the entire energy demand of the Nepal. Anyway, so this is regarding the radiation also. So Nepal is receiving radiation quite well, and we see there is around 300 sunny days which are available. So which is a very good thing for solar. So like I mentioned that, it is estimated that Nepal can, meet 100% of the energy demand if 1% of the land is covered by solar panels. Energy for the pump hydro can also be met with solar. Solar PV storage can be an option for, trading with the neighboring countries, though I believe it is very expensive as of now. And dependency on the oil can be very much reduced if we can further, implement the EV mobility, and we can always have solar run chargers, so which will help, the dependency on the oil. Now coming to Trina Solar, the company was formed in 1997, and we were listed in New York Stock Exchange in 2006. Then, we built a Trina PV Industrial Park, which is 25 square kilometer of area, which is there in a place called Changzhou, which is 200 kilometers from Shanghai. And then we established our state key laboratory. This is laboratory which is being certified by the Ministry of Technology and in China. And I believe this is the only lab which is certified by different testing agencies. In 2014, we became the largest PV module supplier, and the journey was like then we delisted from New York Stock Exchange in 2018, and then we were because of the primary reason that US was not very favorable for the solar industry during that time. So now we are listed in Shanghai Stock Exchange in star markets, and then we have total shipments of around 120 gigawatts globally. Regarding the globalization, we are shipping modules to almost 150 countries, and in India specifically, because we have done almost 9,000 megawatts of module has been shipped and supplied in India, and the total market share is, I believe, we are in top market share in India. So regarding this, like I mentioned, we have 4 regional offices: US, Europe, then we have China, and then we have APAC. So APAC, Asia Pacific, is including Australia. So I represent, or I came from Asia Pacific, and Nepal has been handled by our India office. Well, our chairman, Mr. Jifan Gao, was the founding chairman of CPIA. He was, vice chairman of the China B20 Business Council, and he was the first one to introduce solar in the World Economic Forum, and he is the CEO for the Sustainable Urbanization, as well as the founding member of the advisory board for UNDP in China. Regarding the R&D, because solar is not that simple, you need a lot of R&D activities, R&D capabilities, because every now and then, every 2 years down the line, there is some changes, and if you don't invest any money, then you are gone. We have seen a lot of companies going out of business because of this. So we have invested a lot in R&D, and we have formalized a lot of standards, in the international market, and most of them has been accepted by the regulators. Regarding this laboratory accreditation, like I was mentioning, we were the first in the world to be certified by TUV Ireland for IEC certification, that no third-party inspection is allowed when the test is happening on a Trina Solar laboratory. And similarly, what was first accreditation by the UL also. And we are working very closely with Solar Energy Research Institute Singapore, as well as University of New South Wales, Australian National University. And in our R&D state key laboratory, we have almost 400 scientists working on the new technologies. Some of them are working on how to reduce the consumption of the raw material. Like earlier, the size, thickness of the wafers was higher than it has been reduced, and we are making sure that it is not able to affect the performance of the module. Like I mentioned, we are in a leading technology provider. We have we are working on 210 wafer size, and we are the first one to work with this 210 wafer size. Similarly, we have N-type technology, which is N-TOPCon we call it. The efficiencies are higher, or the wattages of the module is quite better than what we have with monoperd. And we are also working on HJT technology, though it is too early for this technology, because sometimes commercially some things doesn't make sense. But if you are ready with the product and when commercially makes sense, then I think we'll be the first one to be coming into the market. Regarding the photograph which you are seeing, it is a Japan Formula race. So Trina Solar is participating in this. This is a solar powered car, and we are winning this race for almost 3-4 years. Regarding our business, like I mentioned, we are a module supplier. We have a tracker also. So now I think if you, most of you will know that tracker is a product wherein it moves with the sun. The solar, the module will move with the sun, so that you are generating energy, with the sun. So we have a tracker company also. Then we are into system solutions, like we are doing utility solar projects. We are into distributed solar projects. And we have a storage system also. So that way we are like fully integrated as a solar solution company. Regarding our product, we have a high-powered solar modules, which is capacity of around 65 gigawatt as of now. And we are number one in terms of manufacturing for this 210 module production scale. So the wattages of the module start from 580 watt and it goes up to 690 watts. So the times of the technology is changing very fast, and so we are keeping pace with the technology. So what is the advantages of higher wattage modules? It's basically you are saving a lot of, there is a lot of saving in terms of a utility scale projects. Basically is saving in terms of the BOS, the balance of system, and then you have the lower LCOE, levelized cost of electricity. So it's an advantageous to have a better or a bigger format of the module. Like I mentioned, we have tracker also. So we bought a company in 2018 called Enclave, which is a Spanish tracker company having a global installation of more than 8 gigawatts. And our annual capacity is 5 gigawatt, and we have done more than 400 plus tracker projects. During my slide further, I'll be showing you some of the photographs of the large projects that we have done. We have done projects in terms of 500, 600, even a gigawatt also. We are also into storage. So we manufacture battery cells ourselves, with a capacity of 3 gigawatt hours. So we have a battery management system there with us, and we have recently launched a product which is a containerized solution for the battery storage system. Like I mentioned, we have 65 gigawatt of manufacturing. So we have 5 manufacturing bases in China, and 2 of them are in Thailand and Vietnam to cater primarily for the US market. And for cell, we have 50 gigawatts of cell in manufacturing. So these are our codes, our values. Customer is the main focus for us. So we are all customer oriented, very honest, very transparent with the customers. This is all from my side, and I'll just show you a few of the projects. Like this project we have done in Nepal, which is a Durg Amitabha mountain monastery, which is a very remote area. And in 2015, we did this project of 200 kilowatt. These are some of the big projects, what I was talking about, 400 megawatt in Hebei province. And if you see on the right-hand side, lower right-hand side, there is a reservoir, which is 60 megawatt of, floating solar projects. So in India also, we have done one of the biggest solar floating projects with Tata Power, and the capacity is around 102 megawatts. So which is one of the biggest as of now. Similarly, like for agricultural, we have done a lot of projects. For fisheries also, we have done a lot of projects.
Excuse me, time.
Okay, yeah. That's all. Thank you so much.
Thank you, Gaurav. We'll ask more questions if we have. I'd also like to ask audience, if you have any question, you can ask through the app. At the end, we will take that question. And now we have Mr. Takashi from JICA. He's also the advisor for hydropower planning in Nepal. His topic will be capitalizing hydropower resource for the economic development of Nepal.
Thank you, Ananda. It is my great pleasure, and then I'm honored to have opportunity to talk in this conference. My special thank you goes to the chairperson of this conference, distinguished guest, eminent panelist, moderator, and participants, and Hyatt Hotel staff, all make this possible for us. Thank you very much. Yesterday I participated this conference. I found very interesting. There are a few interesting issues raised at yesterday's session. They find one, where is the prominent market for Nepal power? And then the secondly, how do you develop domestic industry? And then the third is international competition, and then the cooperation. I'm not quite sure how I can address those issues, but I'd like to show my personal approach for those. Say, for instance, one is how to expedite power export to India and then Bangladesh. And then the secondary, ammonia development, and then the export to region. And then the thirdly, creative and innovative financing. The first of all, okay, the chart shows the fluctuation of power supply and demand. I guess most of you know those situations, so I will just skip detailed explanation. However, even for the storage project, you cannot expect 100% output throughout the year. There's a fluctuation. And then on the other hand, the demand side, during the peak hour, substantial demand is there. But however, after 7 p.m., there's a big drop for the demand. So you need to deal with those uncertainty and then the fluctuation. This is a future scenario for demand supply. There will be lots of discussions. The figures are debatable. However, I would like to present this as an example. One of the scenario is hydro-middle. Hydro-middle meaning there are projects listed by DOED, survey license and then the development license. If Nepal succeed in developing all those survey license and development license project, this is what you see in the future. This is debatable. In February, there might be some shortage in supply. However, when you look at the majority of the year, starting March through December, you expect significant amount of export capacity. We talked about that yesterday a lot, but I just show you the figure. By the way, this light blue one is a run-of-river, and then the middle one is a peaking, and then the thick blue, navy blue, is a storage. This is what you expect more or less in the future, in 2040. This is on the right-hand side. This is an example of supply, power generation by storage power. By the way, this is a Dudukoshi project. During the dry season, you expect the flat generation throughout the dry period. However, as I mentioned, during the rainy season, maybe 1/3 of the period, you can expect a full capacity generation. However, there will be a drop in the supply. What I see here is you will see the export potential during the rainy season, regardless of the hour, peak hour, off-peak hour, you expect export potential. Now, under the long-term investment plan, you will see the annual balance of trade. In the case of scenario hydro-middle, you expect the solid increase in the power export under this scenario. However, if you are pessimistic, you have to rely on the power import. Of course, you will have a negative the balance in the future. And on the right-hand side, I show you the investment needs over the 20 years, 20 some years. This is a scenario. Starting 2022, you need 50 billion US dollars, 50 billion. On average, yearly, more than 2 billion US dollars on a disbursement basis every single year. If you want to realize this scenario. Okay. This is something we need to look at. Okay, this is the Indian market, just for your information. Many of you may know already. As you know, India is trying to develop renewable energy very, very aggressively. On the other hand, when you look at the coal power generation, India will increase the capacity of coal fire up until 2030. And then after that, they would have some decrease in the generation capacity. Maybe because of the retirement of the old plant. However, still in 2040, majority of the generation would rely on the coal fire. So this is the current plan. And this is where the Nepal can export ammonia to curb the climate change. I will explain a little bit later, okay? And the next one is the Bangladesh now. In Bangladesh, as you know, Bangladesh is generating dominantly by coal fire and then the LNG. And on the left-hand side, this shows the power peak demand in Bangladesh. The Bangladesh power peak demand occurred during the rainy season, meaning, say, July to September or October. Now you noticed, this is the period where Nepal has surplus. So there is a export potential for Nepal. And then when you look at the future generation mix in Bangladesh, Bangladesh is increasing fossil fuel power plant. I guess it's because of they have to. They have no choice. But if they have choices of tapping the renewable market from Nepal, they may have different landscape. Okay, now when you try to export, yesterday many of people talk about the expansion of interconnection. This is one of the thought. I guess NEA is thinking about the similar aspect. Right now, but however, over the period, there will be 6, 7 interconnectors. And then the most strategic and then the important one is 765 kV from India through Assam, India, through Bangladesh. This is where the Nepal export can be brought to Bangladesh. Okay, now let me talk about a little bit the specific one. One of the projects I'm working is Sunkoshi 3, as many of you know. The project is joint venture MOU arrangement between Bangladesh government and Nepal government. The joint venture company will be established sometime. My personal thought is to have Indian government or Indian investor in the equity partner. This is one of the example. Sorry. This is a Bangladesh government and Nepal government. They may be able to secure equity financing. Say, for instance, equity-backed financing from development partners or any financial institutions. And then that they own the fund to executing agency, for instance, BPDP or NEA. And in the case of India, maybe NHPC or SJVN, we are not sure. But by having Indian company, Indian partner as a joint venture company, the investment needs of Nepal would be substantially lower. When you look at the Upper Arun project, Dudukos project, some other mega project, they are working on securing mobilizing the fund.
Excuse me.
By having time. Okay, thank you. Okay, anyway, let me wrap up my presentation. This is a co-firing. Use ammonia in the coal-fired power plant. This is started already 8-9 years ago before the COP21 in Paris. Okay, this is sort of my findings. The export-oriented project needs to be modified. Design needs to be modified. The pricing is different from the domestic market. So the civil engineering design, the electromechanical design would be different. And then the risk mitigation, and then there would be a need to look at the future growth. And then the development of green fuels, ammonia particularly, which will be strategically important for Nepal. And the mobilizing fund, the FDI from Bangladesh, India, and then the securitization of the energy power during the peak hour. So that is another option. And then, of course, a mobilizing fund, every kind of sources. Then finally, the flexibility is important in the power purchase agreement because there are lots of uncertainties, lots of changes in the market. So you want to have options. Of course, you have to pay options, but that would help in the planning. Thank you so much. Thank you.
Thank you, Mr. Takashi. Thank you for inside story of export scenario and all the planning of hydropower in NEA. Now we have Prabal Bhattrai. He will talk about distribution energy resources in Nepali context. He's from KNA Engineering.
Thank you, Anand sir. Good morning, guests, ladies and gentlemen, distinguished guests. First of all, I'd like to thank EPAN for this opportunity. Thank you. So today I'll be presenting on distributed energy resources. So not so much on the innovation side of the resources themselves, but on the infrastructure side. So how do we innovate our system to accommodate distributed energy resources? Our transmission system, distribution system, how do we innovate? And do we need DER when we have ample hydropower potential available in Nepal? So that is the topic that I'd like to cover today. So let me go to my slides. So this is the introduction. And what exactly are DER, right? So distributed energy resources refer to small-scale power generation or storage. So the difference is they are located at the load center rather than the conventional power plants which are located remotely, and then we need huge infrastructure investment on transmission and distribution to supply the demand side. So typically, speaking, DER is less than 10 megawatts, and they include generation storage technologies, also, battery storage and other generation storage technology as well, which are capable of injecting power to the INPS, or the integrated power supply system. They also include PV, wind, fuel cells, biomass, and hybrid generation. And something that has come up, and we need to innovate to accommodate that, is electric vehicle, right? So every country is pushing to cut down their emission and increase use of electric vehicles. So these vehicles, they are small storage system, right? So how can these small storage system be pulled together and brought into our system, not only to take power, but also to supply back to the grid during peak high demand condition. So that is what this DER presents as an opportunity for our power system. So what are the benefits and what are the drivers of DER? So generation balancing and demand balancing. So transmission deferrals. If we can have a generating facility at the load center, then we can defer our investment on transmission. Transmission, as we know, is a huge bottleneck, and not only in Nepal, across the whole world, transmission line construction gets delayed. So resilience and security. So we know that with the climate change, there is changes in the weather pattern. So we've seen this in Texas. So how this DER can benefit and make our system more resilient is we have localized generation. And it is sustainable in the sense that we adopt green technology and as DER. And now we know that the solar technology, the cost has reduced considerably, significantly, I must say, and that's why it is very competitive to the mainstream energy generation projects. So in Nepali context, so how can Nepali infrastructure benefit from DER? Is we can save cost in transmission investment, and we can also defer transmission projects. So demand side management. So if we have a proper PV and battery storage system, then we can manage our demands. And with managing our local demand, that can do is we'll have firm energy that will be available for cross-border trading. If we can manage our local loads with these small DER distributed along the system transmission line, then we can have a source of energy that we can save for exporting to neighboring countries. That's a possibility, but it needs a lot of background work, a lot of planning and distribution and load management, but that's a possibility that we can look into. So worldwide, what is the scenario of DER? So in Europe and across America, DER as a part of green initiative are rapidly connected to the system now. In Nepal, so the era is yet to begin, but we'll have to be very innovative in terms of our infrastructure development planning and also our policy innovation. We need policy innovation. There is feed-in tariff for DER right now, but only a few, I think, believe have that facility used. We can also have very dynamic DER, as I said, taking power in during high generation and giving power back to the system when there is low, high demand. So, but it would rather seem like a regression from the current integrated system. But it's not like that. The current grid operators can benefit from this DER by taking part in this initiative. So So that's one thing that has to be addressed by the policy if we want to go for high integration of DER in our system. So what kind of impact does a DER have, and how the studies and the planning should change is the impact on the distribution side. So conventionally, we always had system impact study done on the transmission side. Now DER requires such kind of study on the distribution side, not on the transmission side. So that's the difference, because we have bidirectional flow if we have enough DER resources in our system. So as I already said, bidirectional flow in distribution substation, which requires unconventional relay and settings. But having said that, these technologies have already come of age in other developed countries. So the technology is there to be implemented. And distribution automation. So as I said, as we go into an era of real-time data flow, we'll have to automate our system with communication system, not only on the transmission side, but also on the distribution side. Optical cables, that's easily implementable. It's only coordination that is required. So, and demand response resources. So as I said, smart grid, smart technology, smart loads, which can turn on and off as per the condition of the grid. So, I don't want to get into the details of system and impact study of DER, but this is just to give you an overview of what kind of impact it may have is over voltage flickering, overloads, grounding problems, increased fault currents and productive device coordination issues, risk of islanding, and harmonic distortion. So these are the things that we should take care before switching to DER. And so this is the future of the grid. This is how a grid will be in the future, right? So we have demand response. Thank you, Answer. I'll take just a minute of your time. And then we have battery storage EV, which are again virtual assets spread across the grid network. And then we have a communication system in place that can communicate real-time data. So we have dynamic load and generation balance. And that brings to my last slide. So I represent KNA Consulting Engineering. So we have done such DR studies, about 700 projects, and they've been implemented in Northeast US. And our team is fully equipped to do such studies, and we can answer your questions if you have any. Thank you. Thank you so much.
Thank you, Prabhalji. Very interesting. Hope our policymaker will take home this, and we'll soon implement this in our system also. Now we have Namit from Sungro. His topic is technology advancement in solar inverter technology.
Hi, good morning, everyone. And thank you, Power Summit team, for inviting us over here. So I'm representing Sungro Power. We are the leading solar inverter manufacturers with over 350 gigawatt plus supplies globally. So this is our journey so far. We were established in 1997, so we are already 25 years plus old company. We are having manufacturing facilities in China, India, and Thailand. So globally, as I mentioned, 350 gigawatts plus supplies has already been happened. We are a Shenzhen Stock Exchange listed company. So these are various divisions where we are basically into. So we are a purely renewable sector company. We are into the manufacturing of solar PV inverters, battery energy storage systems, floaters, even developing solar plants, and providing robotic cleaning equipment, wind energy converters solely dedicated to the renewable sector. So this is our growth so far. So this is how some of the projects being done, like I mentioned, presence in 150 plus countries and worldwide supplies. Some of the market references, I'll just quickly run through it. So in India, we were, started our operations in 2014, and Till date, we have supplied more than 15 gigawatt plus inverters, and with a factory in Bangalore exporting not only to countries like Nepal but US as well. So as I mentioned, these are some of our strengths, like supplies in India and up to 25 plus inverter models being supplied. Talking about inverter technology, so we were the first player, to introduce ratings such as 2.5 megawatt inverters, 3.125 megawatt inverter, and now recently we have launched our new 1 plus X inverter, which is actually transforming inverter technology, and I'll explain more about it shortly. This is our factory in India with 10 gigawatt plus production capacity annually, and globally, if I talk about including our factories in China and Thailand, it's more than 150 gigawatt plus annual capacities that we have. Some of our achievements in India, I'll just go through it. So as you can see, we have a pan-India network. So the same service network we are trying to utilize even for Nepal, because time being favoring thing here, because it's like 1.5 hour flight, so easily our engineer can fly over to Nepal for any issues. Plus we are having a local partner here to cater to the immediate service requirements. So this is how we are planning to cater. This is the, talking about technology, this is how we are panned out in all the sectors: utilities, CNI, residential, having all the monitoring products as well. In utility, as I mentioned, we have a varied product lineup. Talking about the range, it starts from 5 kilowatt up till 5 megawatt. So all the various range of products are available. Energy storage systems, we are manufacturers of PCS. Also in collaboration with the battery companies, we are manufacturing the battery as well. And complete system, including EMS, PCS, monitoring system is being provided. So these are some of the major clients globally that we have. So I'll play one video showcasing our recent product. This will explain how the inverter technology is actually growing, and recently it has moved to which product. So I'll just like to display a video here. If you can play the video, please.
In the new age of integrating PV power generation and energy storage, Sungrow has launched a 1+X solution for large utility plants to significantly innovate traditional inverters and thereby promoting high-quality development of innovative power grids. 1.1 megawatts modular units can separate up to 8.8 megawatts support on-demand configuration and flexible combination. Multiple MPPTs adapt to different regions and terrains, and PV plants can be designed more flexibly, thereby improving power generation efficiency. A combiner box supports 16 to 24 inputs, reaching a DC-AC ratio up to 2.0. The solution supports 1 to 4 hours DC coupling energy storage system, deeply integrated with PV power generation. Plug-and-play modularized component design eliminate the need for professional maintenance personnel, improving maintenance efficiency by 70%. In case of a fault, the fault inverter unit can be easily replaced by spare unit without impacting on other operating units. This improves the uptime rate and reduces power generation loss by 95%. PV power generation and energy storage are designed on the same platform. Up to 90% versatile parts and 50% fewer component types, simplifying spare parts management. Dual independent cavities design, including direct ventilation for power cavity and heat exchanger ventilation for electronic cavity, Mix the whole inverter with IP65 ingress protection applicable for all weather and adapts to variety environments. Intelligent IV scan. One key diagnosis. Accurate fault location. Easy data export. Brings efficient and convenient O&M, improves power generation and plant safety. Real-time DC arc detection. Realizing quick disconnection and synchronous linkage for automatic fault removal. Plants can operate stably in weak power grids with an SCR value of 1.018. Reactive response within 20 milliseconds, far shorter than required in national grid codes. No disconnections occurred during UHV continuous high and low voltage ride through tests. The solution was the first in the PV industry to pass the Qinghai-Henan UHV tests. The inverter can communicate with combiner boxes over a wireless connection, which reduces cabling expenses and lowers the initial investment. Higher power density, larger block size, lower watt cost of MV station. The self-grid construction solution shortens the construction and commissioning period, brings earlier grid connection and more power generation. The solution uses a device to disconnect the medium voltage transformer to avoid no load loss at night, reducing electricity costs. Specializing in conversion of clean power, Sungrow continuously drives industrial development through innovations and mines the benefits of integrating PV power generation and energy storage to accelerate the advent of a zero-carbon future.
So, considering the challenge of land we have in Nepal, and not only Nepal, in a lot of other countries. So this is, one of the technology that in future would be, really helpful, not only to optimize the land usage, but also to, optimize the levelized cost of electricity. So that's it from my end. Thank you.
Thank you. Now we have Gen Malvik from World Bank. He's senior hydropower engineer. Now I'd like to ask you something. In Nepal, we have not practiced pump storage, and you also please let us know how hydro and solar is complement to each other. Like now we're saying solar is coming, why solar is coming, as we already have a lot of hydropower resources. So you can complement on this issue and pump storage and new technology, all what we want to use in hydropower.
Absolutely. Thank you so much, and thanks for having me today and allowing the World Bank to talk on this very important topic. We are really trying to be a front runner in the field of innovative technologies. I don't have any slides, no worries. I'll just speak for a few minutes. We just have a few minutes left. I'll try answering some of the questions from the audience as well. So this was a highly interesting session, and we've seen many advancements in technologies that the World Bank is actually trying to implement on our ongoing projects. Currently, we do have a portfolio of 8 gigawatt of hydropower plants in Southeast Asia region under development or under constructions. And on all of those projects, we are trying really to keep up the pace with the most recent technologies. Now, there was a question from the audience as well, whether this relates only to the IT or the electrons. Yes, for the time being, but I'll come back to that one immediately. So on the IT front or new digital technologies, we really try to be up to speed with the most recent developments. And I'll just try giving a few examples. Building information modeling, BIM, is something that we are currently looking into and implementing with some of our projects. Remote sensing for disaster risk management, extremely important here in the Himalayas. We are trying to build on our own experiences from India. We have an ongoing construction project in Uttarakhand that was heavily affected by GLOF a few years ago. Remote monitoring for execution, another very new technology, which was very relevant, very important for us during COVID times when we actually were unable to physically visit the sites. Drone surveying for DTM, and so on and so on. There is a number of examples of new technologies that we are currently implementing on our projects. But then there was a question from the audience whether this all is constrained to new digital technologies only. And the answer is actually no. Just a few months ago, I mean, although hydro is very mature technology, just a few months ago, a major European turbine supplier has announced the first ever horizontal 6-nozzle turbine. And this is something we want to see in place. This, for all the people who are knowledgeable about turbines, they do know that the previous limit was like 3 nozzles, but this gives space actually to replacement of the old and deployment of new plants. Let me talk a little bit about our current engagements, especially in India on pump storages, and I guess this will be of relevance for you here as well. Pump storage is coming back big time globally, especially in India. There was a huge turn of the past 12 to 18 months, and just last week actually, the Indian CEA has released new guidelines for PSP developments in India. What we are trying to develop in the World Bank is try to identify 2 tracks of projects. The first one is a kind of a more conventional PSPs that are closed loop systems of the river. And then since just transition is something that we are pursuing globally, we are trying to look into the options to deploy pump storages at repurposed coal mines. Not that relevant for in the case of Nepal, but still we do think that pump storages will be very much needed throughout South Asia region, and we are here actually to support our clients on this front. You mentioned combination of hydro and solar. We've seen some example of the past 2 days. We are currently working with a client in India and Himachal Pradesh to try securing round-the-clock power to the suppliers in India. This will be very much needed. I don't have to go into all the details of the future grid. And maybe last, innovative storage technologies. This is another area where we are trying to be a front runner. We are all aware of the constraints related to BESS. Pump storages have long gestation period. So what we are trying to do currently, we are doing a study on deployment of alternative energy technologies, gravity storage, solar thermal, phase change storage. There is quite a few examples globally, some pilot projects already in place, but this is highly related to just transition of coal industry that's happening globally. So we want to see how, in the best way to deploy these new technologies that will be actually quite needed in the grid of the future. So let me stop here. I'm quite cognizant of the time.
Thank you, Janan. We have questions from the audience. So I'll ask some of the questions. We have the question from Sandeep Shah. NE has started process for reverse auction with very low benchmark. Will solar project will be viable with such a tariff? What will be the acceptable FIT?
Well, I think, it's a very okay. So what I believe, like recently I, have seen that NE have reduced the cost of, this solar tariff to 5.9 in Nepali rupees. So which is equivalent to almost 3.5 Indian rupees. So you cannot compare the reason I believe is basically like India is having a tariff of 2 rupees 40 paisa. But I think, Nepal context is entirely different from India because the cost of the land here is quite expensive. And it is a very, very scarcity also, it's difficult to find. So I believe tariff should be like more than, something in tune of, if not 9 rupees earlier, can be around 8 rupees or so, wherein the, the developer also is able to make some money out of it, yeah. So currently the tariff is too low, yeah.
Thank you. Takashi, you have a question from Priyanka Ronier regarding financing. What are the financial tools on overcoming largest challenge faced by investment cost? Is it feasible for Nepal market too? What are the financial tools on overcoming large challenges facing by investment cost?
terms of the in terms of the financial tools, traditionally the public project mobilizes from the development partners, but now it's changing. Financial institutions, citizens fund, pension fund, etc., etc. But what I think is the domestic mobilization could be limited given the size of investment needs. That is why I propose foreign direct investment from not just Bangladesh and India, but also other parts of the world. So that
Thank
is
you.
what I...
Now over to Sadisya.
Thank you very much. Can we have a big round of applause for this panel that discussed on very important topics, power projects, innovation and technology. Now, along with the questions that the audience posed towards our panel, there also poll that is going on. So if you haven't yet casted your vote, we highly encourage you to do so. There are currently 2 polls going on for this session. The first one is, what should the ground-mounted solar feed-in NEA tariff in Nepal be? And the other question is, will over-reliance on hydropower backfire on Nepal? So those are the 2 questions. You have your options as well. So I'd like to request all our distinguished audience as well to kindly take 30 seconds just to look at these questions and cast in your votes. I hope that you have already downloaded the Power Summit app that will also give you access to and the contact details of many of our speakers, panelists, presenters, moderators. So we definitely hope that you have downloaded the app. Will over-reliance on hydropower backfire on Nepal? Yes, no, and maybe. Those are the 3 options for you. What should the ground-mounted solar feed-in NEA tariff in Nepal be? Rupees 4 to 5 per kilowatt, 5 to 6 per kilowatt, 6 to 7 per kilowatt, or 7 to 8 per kilowatt. So these are some of the options for you. I hope our distinguished audience also takes in some time to cast in your vote. We'll have a look at what majority of you have voted for. What should the ground-mounted solar feed-in NEA tariff in Nepal be? Majority of you have voted for 5 to 6 NPR per kilowatt, with 4 to 5 per kilowatt following after that, and then 7 to 8 per kilowatt, and the last 6 to 7 per kilowatt. Thank you very much to our audience for participating in this poll. We'd now like to move on to the other poll, which was, will over-reliance on hydropower backfire on Nepal? A very important and crucial question. 41 of you have said no, it will not backfire. 19 of you have said maybe in between, it might or might not backfire. And then 17 of you have casted your vote for yes, over-reliance on hydropower will backfire on Nepal. So thank you very much to our moderator, to our panelists as well for this discussion. And to present the token of love now, may I please invite on stage Ms. Kavita Pokhrel, Executive Committee member of IPPAN, to present this token of appreciation to our moderator, to our presenters and our panelists. We'd like to thank our moderator, Mr. Anand Chowdhury, Treasurer of IPPAN. Thank you very much for moderating this session extremely well. We'd also like to thank our presenter, Mr. Janan Malovic, Senior Hydropower Engineer, the World Bank. We'd also like to thank Ms. Abhigya Malla, Vice President, High Himalaya Hydro Construction Private Limited, for showcasing a fantastic presentation on the best practices in construction of hydropower projects. We'd also like to thank Mr. Gaurav Mathur, Country Head, Trina Solar India, for showcasing the latest trends in solar PV technology. We'd also like to thank Mr. Takeshi Kikukawa, Hydropower Planning Advisor to NEA, for his inputs on capitalizing hydropower resources for the economic development of Nepal. We'd also like to thank Mr. Prabal Bhattrai, K&A Consulting. He talked about the transmission system design and technology. We'd also like to thank Mr. Namit Anija, Regional Sales Head North and East India, Nepal for Sungrow India, for his views on technological advancement in solar inverters. And we'd like to end with a group photograph of this panel. And then we conclude session 10 here at the Power Summit 2023, where we are talking or having conversations around broadening green energy markets.
Welcome to Power Summit 2023.